My whole aim was I want a shop full of GT-Rs. When I first opened in 2008, it was just, that was it. That was the goal. Because I was an enthusiast first and then started the shop later as a result of my passion for the car, you sort of still look at them and you go, man, I can't believe this is what we do every day.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're speaking with Anthony from Dartone Racing from Sydney, New South Wales in Australia. Now, Anthony is a specialist in the Nissan GT-R, and for those joining us from the North American market, we're not talking R35 here, we're talking the R32, R33 and R34. And I think the GT-R world love affair has probably been spawned from the Fast and the Furious movies, and we've seen, particularly over the last decade, the prices of these cars soar to crazy heights. Back about 8 or 9 years ago now, when I sold my business, a good quality R32 GT-R in stock form here in New Zealand was probably going to set you back somewhere in the region of about 15 to maybe $20,000 these days. That soared to in excess of 80 to $90,000 if you're looking at an R34 GT-R. We've seen these trading for $300,000-$400,000 depending on the spec and desirability. So they are becoming an insanely valuable car. Despite that, particularly in Australia, there is an avid street scene with these cars. There's a lot of fierce competition between shops. The fastest street driven or street legal, if you like to call it street legal, GT-R is into the 6-second zone now, and that's incredibly fast for anything, never mind something that you can actually still drive on the street. Now, of course, the R32, 3 and 4 is all really based around the Nissan RB26, which has become an engine that is sort of reached almost mythical status, and maybe, as we talk to Anthony, not for some great reasons. It's actually a bit questionable because there's a huge amount of problems with the RB26 engine that you're going to need to overcome if you want to take a street-driven RB26 and turn it into something that's punching out 500, 600, 800 horsepower or more and doing it with reliability. So this interview with Anthony is going to really appeal to the RB26 lovers out there, and we dive deep into the tech of the RB26 engine, the different variants, the problems that you're going to face, and of course the solutions for those problems. The great news is that you can solve all of these problems. Just chuck a bunch of money at it. And fortunately, these days with the aftermarket industry catching up with our desire for aftermarket parts, this has become a lot cheaper than it was maybe 10 or 15 years ago building these engines. It's still no joke. Anyway, it's not just a conversation about GT-Rs though. There is also an element of talking about how Anthony has built up Dartone Racing as a business and his mindset and mentality around operating a business, punching out high quality product that he knows is going to meet or exceed his customers' requirements. So for any of you who are listening who maybe are already running an automotive performance workshop, or maybe you're thinking about starting one, there's some great nuggets in there that will be really valuable. Now, before we jump into the interview today, just for those who maybe aren't aware of who we are, High Performance Academy is an online training school, and we specialize in teaching people how to build high quality, reliable engines, tune aftermarket and factory engine management systems, build quality and reliable wiring harnesses. We also cover other topics including fabrication, car setup and race driver education. Based on today's conversation though, if you like what you hear, a couple of our courses that I believe would be really good additions to your knowledge base are our Engine Building Fundamentals course and our Practical Engine Building course. And this breaks down all of the information you need to understand about the operation of an engine, the machining involved in getting your engine ready to build, the part selection process, clearances inside the engine, and then of course the actual actual practical steps involved in building your engine. In particular, the practical engine building course, it is going to work irrespective what engine you're building. We provide you with a really simple to follow 10-step process that you can apply irrespective of your engine brand, whether it's a pushrod V8 or maybe it's a quad cam V12, same steps will go. You can also watch that 10-step process being applied from start to finish in our library of worked examples, and that's where we dive deep into the engine building process on a specific platform. Now, if you are interested, we will drop a link in the show notes for both of those courses, and as an added bonus, as a podcast listener, you can use the coupon code podcast75, and that will get you $75 off the purchase of your very first HPA course. Again, we'll put that coupon code in the show notes. All right, that's probably enough of our introduction though. Let's jump into our interview now. All right, welcome to the podcast, Anthony. Thanks for joining us today. And as we do with most of our guests, I wanted to just get started by learning a little bit about your background. How did you sort of get started modifying cars and get to a position where you started and run your own workshop?
Yep. Well, thanks for having me. So essentially, I grew up around cars my whole life. Three of my uncles had workshops, a panel shop and a mechanic shop. And from when I can remember as a little kid running around the panel shop looking at all these cars that they were sort of doing restos on and, paint jobs and all that kind of stuff. Started with building little model cars with them, and then basically just progressed from there, always pulling things apart and trying to put them back together as a kid. Once I got a driver's license, naturally you get a car and then you sort of start playing with it, tinkering with it, trying to personalize it, make it your own sort of thing. It just basically progressed from there. Did my time with one of my uncles as a mechanic. Started my apprenticeship there and just did a little bit of other sides of the automotive industry. Like I went and did SRS airbags and ABS, fault finding, all the diagnostic stuff. We used to do that. From there, it progressed to, wanting to modify cars and just do all the performance side of things.
Now, a lot of those skills that go into just regular mechanical work, the likes of what you learn through an apprenticeship, I mean, that is obviously a solid basis for working on just about any car.
Yeah, definitely.
But I find that those skills often don't kind of naturally cover off everything to do with performance modification. I mean,
no.
There's some crossover there naturally, but also they can be quite separate. So, I mean, not every mechanic I come across, they may be a very capable mechanic in their own right, but that doesn't always mean that they're good with modifying cars. So, can you talk to us a little bit about how you built up that skill set of what to do when it comes to modifying?
Yeah, so obviously, an apprenticeship gives you the basics. It teaches you what tools are, how tools work, how basic cars work. Your basic systems, your braking systems, and how your engine works and all that. When we were going through TAFE, obviously it wasn't a lot of EFI stuff, which it sort of doesn't really translate into what we do now. But it's mainly just to get the basics there, and it's a requirement in Australia to get your mechanical license. So I was doing, mucking around with things prior to going to TAFE anyway. So everything sort of started when I bought my first Skyline, maybe 2001, when I started moving more towards that performance side. Like I built my first RB2530 combo in 2003, just by myself, worked it out as I went, and that's sort of, just go bit by bit through it and tinker with your own stuff before you obviously tinker with other people's, and that's sort of how it all came about.
There's a couple of things that you've just mentioned there, so I just want to sort of head back a little bit.
Yeah.
And you mentioned that the TAFE training, for those who are outside of Australia, TAFE, as I understand it at least, is essentially like a trade qualification school. Is that about right?
Yeah, that's right. Yeah, it's like after you finish your normal schooling.
Yeah.
It's just another another training sort of organization thing.
Yeah, we have similar over here, although it's not called TAFE, and I think the same goes. At least what I saw, we used to have a few Polytechnic students coming through my old business doing sort of after hours work and helping us out, and the same deal. Basically, they weren't really diving into EFI modern engines. Everything they worked with was old school, probably single cam or push rod, 4-cylinder stuff, and really basic carburetor. However, I would say that when it comes to the engine basics, it still comes down to fuel, air, spark, and compression. And I see that's the sort of the real basics that still, for me at least, is the fundamentals of a lot of the fault finding we do in the industry. And a lot of the mechanics that I come across still kind of struggle with some of those basics. So do you sort of agree that understanding those principles is really important, irrespective of how advanced and modern the car is that you're actually working on?
Oh, definitely, because at the end of the day, an engine's an engine, and they all work the same way. If you haven't got those fundamentals, if you haven't got, your spark, your compression, your fuel, it's not going to run regardless. It's not going to work regardless. And if you don't understand how an engine works, diagnostics is going to be, not impossible, but very difficult, and it's going to take a long time if you don't actually understand. And you can get tied up in, hours of trying to fault find something through guesswork, which I see happen all the time. And you need to know, regardless of what you're doing on a car, as if it's to do with the engine, you have to understand how the engine works at its most basic.
Yeah, I agree. I think a lot of people get overwhelmed, and again, even those who maybe have a fair bit of experience in the industry get overwhelmed with what they're working on and kind of overlook those basic principles. So I always find when I was faced with a car on the dyno that was misbehaving or wouldn't run or whatever it happened to be, sometimes you just need to sort of stop and come back to those basic principles: fuel, air, spark, timing, fuel, air, spark, compression, and check those off, and then you can start getting a little bit more detailed. The number of times I see people go down an expensive, long-winded rabbit hole where if they actually just stuck their head into the engine bay and found that the ignition lead, for example, was hanging off, that's a much cheaper fix.
Yep, definitely happens,
You also mentioned that as part of this, I'm guessing you mentioned the SRS, airbag, ABS diagnostics. Did you find that was a useful sort of addition to your toolbox, I guess, of skills, being able to diagnose those problems, which also transitions across to the rest of automotive?
So the SRS side of things, we don't do a lot of that. We get the odd car in with airbags that has a problem, and because I've got that background, I did it for probably 3 or 4 years. It's easier for me to find those faults and know what to look for. But the same with the ABS side of things, we use a lot of, wheel speed sensors and all that for data logging and with, certain strategies, traction and flat shifting and all that stuff. So, I know how it all works, and I didn't have to really learn it later on because I already knew from before. But the whole diagnostic side of it, where we would go from workshop to workshop and fault find cars for other mechanics, that helped a lot because you understand the process behind it a bit easier instead of, trying to guess your way through it. And I did it when I was younger, so we sort of started with cars that were pretty primitive with the fault codes and things like that, and got to some pretty complicated stuff later on with the drive-by-wire, when drive-by-wire started coming in and things like that. So we got that transition that we can apply now. We went through that transition and we learnt all these systems as they were new and still coming through.
All right, let's talk a little bit about the engine building side of things. Mm-hmm. And again, at least in New Zealand here, with the training that mechanic will go through for qualifications, there's a certain element, as I understand it, of learning what goes into building an engine. But again, this is more likely to be very basic pedestrian sort of car stuff, not dealing with performance engine builds with forged pistons, etc. where did that knowledge come from? How did you learn how to go about that? You mentioned you built an RB30-25 combo. Where did the knowledge there come from?
So here there's a whole separate course for engine building. They call it engine reconditioning, which mechanics don't do that. So that involves all your machine work and all that kind of stuff. So we never got to do that part of the training. And especially performance, there is no course for performance engine building. So you can't go to anywhere and learn it. It's one of those things. I learnt it on my own through, hours and hours of research online. And, I was a big sort of pretty heavily involved in the Skyline community in the early 2000s. And, you just hunt through forums and find information and then see, like, from the knowledge that I had on how engines work, you can look at it and go, okay, well, this might work. That is not really going to work. And you just sort of find your way, with just get all the information you can and try and get through it and find out what sort of makes the most sense. But essentially, it's all trial and error, you know.
I mean, it sounds like your experience pretty much matches mine when I started my own shop, and fairly early on in that, I was building my Evo drag car, and over here in New Zealand, we obviously have engine reconditioners just like every country, and it's a bit of a mixed bag, and I'm not trying to sort of speak poorly of the engine reconditioning industry. The reality, however, is that 99.9% of the time, most of these engine reconditioners are just rebuilding basic, run-of-the-mill factory engines to factory specification.
Yeah, exactly.
They're not spending a lot of time taking an engine that made 300 horsepower and modifying it to make 6, 8, 900, 1200 horsepower, whatever it happens to be.
Yeah.
And therefore, it becomes really hit and miss, the quality and results that you get, at least here locally in New Zealand, which is why I decided to do it myself. Not necessarily at the time because I thought I could do better, just more because that way I knew exactly what was done, and if something went wrong, it was all on my head. But as you say, I mean, a lot of it becomes, searching out what other people are doing, trying to kind of sort fact from fiction, because unfortunately, while forums are a great place, there's a lot of misinformation in there as well.
Definitely.
Sometimes purposely, sometimes because people don't know any better. And it's, of course, one of the reasons why we ended up developing our engine building courses, because I do feel, there is a disconnect between what a engine reconditioner will learn when they go through their training and that extra step that's needed in order to build a quality performance engine, which the likes of yourselves, you've learned that the hard way through trial and error. Now, clearly, you're a Nissan guy at heart, and it's not too difficult to see that if you have a look on your website or your Instagram. We've been traveling to Australia for as long as I can remember, covering events like World Time Attack, and over that time, I don't know, Sydney in particular seems to have become a hotbed for the Nissan GT-R community, and I'm talking here 32, 33, 34, more than the R35. What's going on there? Why is Sydney really embraced that Skyline GT-R platform so deeply and gone so sort of hardcore on them?
I couldn't tell you, to be honest. Look, we've always had, the odd GT-R floating around on the streets. You'd see them here and there, but the amount that you see now is crazy. Like, there's so many of them, and there's so many big power cars that just roam the streets. It's I don't know why Sydney, in particular, ended up that way. Look, I guess they're fast, and there's quite a few shops in Sydney that specialise in RBs, and that's probably the main reason why. We sort of pushed the envelope in Sydney. Well, all the fast GTRs are really from here. So
is it sort of become a little bit of a inter-workshop sort of status symbol or battle as well there?
Yeah, look, there are a couple of shops out there that are sort of all competing against each other to go faster to drags, and that not really what we're into. It's sort of not my thing. I've been doing Skylines and GTRs since the early 2000s when they were worth nothing and no one was really interested in them, so it's
Bring back those times, I say.
Yeah, well, yeah, you buy a car for 10 or 15 grand and just do whatever you want with it. Now it's more of a, I don't know, people are starting to look at them as investment pieces now and things like that, but I've always had that love for the GTR. My whole aim was I want a shop full of GTRs. When I first opened in 2008, it was just, that was it. That was the goal, Well,
it seems like you've met that goal.
Yeah, look, it's good. I come in here every day. I look around and I still, because I was an enthusiast first and then started the shop later as a result of my passion for the car, for that particular car, you sort of still look at them and you go, man, I can't believe this is what we do every day. Every day we come in here and there's, 15, 20 GTRs here and we look at them and just go, man, this is crazy. It's sort of surreal,
So here on this side of the world, Australia and New Zealand in particular, I think that Skyline GT-R, particularly the R32 model, kind of ended up getting mythical status because of its success in the Australian Touring Car Championship, particularly Bathurst, where it basically just destroyed everything in its wake, even though it was continually loaded up with more and more limitations on it to try and keep it competitive. So, I mean, I know other people on the other side of the world probably didn't see that success, but that definitely, for me, the R32 from that point on was always sort of something of a car I really aspired to own. I still do.
Yeah.
With that engine though, the RB26, that powered the 32, 33, and the 34, and it's kind of again almost reached some kind of mythical status, rightly or wrongly, because these days we also see everything associated with the RB26 kind of it attracts what I call GTR tax.
Oh yeah, but you're not wrong there.
In terms of the actual engine, is it anything that special? How does it compare to, because it's old now, how does it compare to something a bit more modern, like, let's say, the VR38 from the R35?
Oh, look, I think it's just because the car has a cult following. Look, there's no secret. The RB26 isn't a brilliant engine. Look, it's good, but it's not amazing. There's many problems with it. There's heaps of problems. They're small capacity. They got, for what they were back then, they're cool. They were built in the 80s, whatever it was, and it was crazy back then. But now, you look at the VR38 and guys are making 1,500, 2,000 horsepower and driving around the street just cruising like a standard car. Whereas, an RB, you get to 1,000 horsepower, it's nice you can make it nice on the street, but the reliability is just not there anymore, at that level.
Sure. Yeah, you're definitely really pushing the boundaries to make an RB streetable at that sort of power level.
Yeah.
And of course, there's always been the fairly heated debate between the superiority of the RB26 and the Toyota 2JZ, kind of two supercars from Japan, I guess, of the same era. Off on a tangent a little bit, but where do you sort of see the two stack up there in terms of superiority?
Don't like to go down that path because we all know we all know the answer, but.
Hurts too much to say?
No, look, I've said it all the time. Look, I wish the RB26 had oil drain backs like a 2J. I've always said that, and an oil pump like a 2J. But it is what it is, and we just live with what we got. When you're a diehard Nissan guy, you just stick with it and deal with all the problems that we have with these engines.
All right, well, let's dive into a few of the more significant and well-known issues with the RB26. Where would you sort of start that list?
Oil control is the first one. The biggest thing is keep the oil in the sump. Once you sort of get around that, oil pumps are easy to fix these days. That busted oil pump problem, that's been and gone. There's so many alternatives out there now, with aftermarket pumps, billet gear sets, dry sumps, all that kind of stuff.
Now, just for those who maybe aren't sort of super geeked out on the RB26, so that stock oil pump, it's a sintered metal construction, and at least from my experience, basically about 8,000 RPM above that point, they're just going to shatter and oil pressure is gone bye-bye.
Yeah, look, it's more so to do with the short nose crank as well. Like they had like about a 5 mil drive on the early RB26 cranks. Those ones used to fall apart.
Yeah, that was a bit of a bizarre setup how they didn't have full engagement. It was almost like you looked at it and thought, what, did the engineers just make a mistake here? Did someone not check the drawing?
It just doesn't make any sense at all, but the RB30 cranks were like that too. So it's like, okay, because the RB30 came out first, it's like they went, all right, well, that's the oil pump drive we're using. Let's just continue that on. And then obviously there's harmonic issues as well with the 2.6 that will bust oil pumps and, balances and things like that. But again, the factory oil pump, look, it can, if you've got a long nose crank and a standard pump, there are ways to keep it sort of together for a certain amount of time. But eventually you're going to have problems. Like it is what it is. You can't change it.
But back in the day, your options there were really limited in terms of when this was an engine supported primarily by the Japanese aftermarket. You had the likes of HKS and Jun, I think, made aftermarket oil pumps at huge prices. But now you've got support from a lot of companies. Nitto, I know, do a fairly well-designed and developed oil pump, along with no doubt many others. So as you say, that's a relatively easy fix now, correct?
Yeah, like you can just buy any aftermarket pump. Look, they do cause other issues because pretty much every aftermarket pump you buy is a high volume pump, as well as having, all the, the billet gear sets and billet backing plates and all that stuff. So
you're actually pumping more volume of oil per rotation. So it fixes one problem, but actually kind of exaggerates some of the other issues which you talked about, keeping the oil in the sump. So
yeah, that's right.
Before we talk about that, the oil pump drive though, so again, we talked about the R32 crankshaft had that short sort of flat drive for the oil pump. If my memory serves correct, from the 33 onwards, they actually went to a full engagement, didn't they, on the factory crankshaft?
So it was Series 2 R32 where they changed it. So 89, 90, partway through 91, off the top of my head, were short nose. And then from like late 91, when the Series 2 started, they were all long nose after that. You never know. You can get a car. You can get a 33 GT-R and it could have a short nose crank in it, because in Japan, they just chop and change engines before they export them, and it's just out of control.
So it's a bit of a luck of the draw as to what you actually get. Yeah. So the question I had there, if you've got a short nose crank and you're not going to an aftermarket crankshaft, even if you're going to an aftermarket billet oil pump, you still need to go to the drive collar to get full engagement. Is that correct?
Definitely, yeah.
Yeah, okay. Yep. And that, for those who aren't aware, the drive collar essentially is a modification to the factory crankshaft that gives that full engagement.
Yeah. So you machine it down, interference fit the new collar on there, and then you get your full around 15 mil of engagement on the oil pump gear. Okay.
All right. So back to our next issue, which is the keeping the oil in the sump. So can you talk us through where the issues are there? What's actually happening here?
Well, if you ever see an RB26 block with no head on it, they've got oil drain backs on one side of the block and not the other. Why? I couldn't tell you. It just doesn't make any sense. So, and they're only small holes as well. So you get so much volume up top that you can't drain it back fast enough. Then you also have the other problem of crankcase pressure not being able to get out of the sump. So you've got oil coming down, and then you've got crankcase pressure going up through the same 5 holes or whatever it is. And it's just all sorts of bad, just it doesn't work,
And this is made worse when you're operating the engine at sustained high RPM, because you've got definitely that oil pump spinning around, punching all the oil up into the cylinder head, and it just basically drains the sump to the point where it's pumping air, correct?
Yep. And that's why you see so many RB26s or RBs in general with spun bearings or that, things like that, because people don't realize what's actually happening inside. They think, oh, it's a Skyline, I can get in it and just, flog it, and it's going to be fine because that's what it's designed for.
Okay, so what are the workarounds? What are the solutions here that the aftermarket have come up with to fix these oil drain back issues?
Yeah. So lots of workshops do things differently. There's all different ways to go about it. Some guys will sit there and tell you that the only way to do it is to dry sump it. You dry sump it, all your problems go away. Yeah, that's fine, but it costs you, $15,000 for a street car. It's a bit overkill, depending on what kind of horsepower you're making and things like that. Then you'll get guys that say, "Oh, head drains are a waste of time." So they make head drains that go in the back of the cylinder head. You run an external hose that lets the oil return back to the sump once it gets to a certain level in the head. I run them on all my engines. I find for a couple $100, whatever, you put it on. Some guys will say it doesn't do anything. For us, it works. So we run head drains.
Cheap insurance, ultimately.
Yeah. The biggest thing I found that's helped us, especially with cars that make, 900, 1,000, 1,200 horsepower, venting the crankcase. So we always vent the crankcase. We've got a catch can setup that we run. We put big breathers off the cam covers, big -12 breathers, and then we have a -10 crankcase breather as well to the top of the catch can. And we've seen that has changed everything for us.
So that's just basically removing that positive pressure that you're going to get in the crankcase at high boost, high RPM, which in turn is allowing that oil a easier job to get back into the sump. Okay.
Yeah, so the oil drain backs can do their job. They don't have to vent the crankcase pressure. They can just, have oil going back down to the sump.
Yeah, okay. The other modification that's pretty typical is the little oil restrictors that go between into the top of the block. So that seems to be a bit of a mixed bag for those who may be fresh to the RB26 engine. There's information for the likes of Tomei who make these. You can obviously make them yourself, but there are different diameters. Is there sort of any guide on what diameter is the key? I mean, on face value as well, it sounds a little bit scary because you are then restricting oil flow into the head. Obviously, we still want some oil up there to lubricate the camshafts, etc. So, can you give us any sort of info on that?
So, the way most manufacturers will tell you, they'll just say, look, like Tomei, they'll give you a 1.5 mil restrictor with your head gasket when you buy a Tomei head gasket, and people think, oh yeah, that's fine. I'll put a Tomei oil pump, I'll put a Tomei restrictor, Tomei head gasket, and it'll be fine. It's not. 1.5 is all right for a factory pump with billet gears in it or something like that, or a factory pump with factory gears. All the high volume stuff, you need to run a smaller restrictor. It also depends on, how much oil pressure you have. Obviously, pressure is related to flow as well, so it all makes a difference. We normally run 1.1 mil for the big sort of pumps, and that works. Like, especially when you've got a solid head. So RB26 head's obviously solid lifter. You don't need as much oil up there. If you've got a hydraulic head, like an RB25 Series 1, Series 2, not a Neo, then you need more oil up there to feed those hydraulic lifters. We don't do a lot of hydraulic stuff anyway, but there's all different things, and then it also depends what you're going to use the car for. So if you're doing circuit work, you need different ones. If you're doing drag stuff, you need different restrictors and things like that.
So it's not a one size fits all solution there. There's a little bit more to it.
Yeah, unfortunately, it's not. It's not that easy.
Yeah, okay. No, I mean, that's fine. I think it's enough for our listeners to understand that there are options there, and there's some decisions that need to be made. A lot of this also comes down to sump design as well. I mean, obviously, if you've got no oil in the sump because you've pumped it all up into the head, it doesn't really matter how well baffled your sump is. It's not going to save you. But once you've got on top of some of those issues, you sort of talked about the $15,000 dry sump system versus other options. What do you sort of do with a factory wet sump? Are you extending the sump to increase the capacity and adding baffles or trapdoors or anything?
So we have a setup that we use constantly. All our wet sump engines get a high octane sump extension. It's got baffles in it. It's about 9 liters. Fits perfect. Like, they do the whole job for us, and we just bolt it on, and it works. It's nice. It looks good. It comes back brand new, pretty much, and rebuild the diff and put new seals and everything, and then off you go. So that's our go-to. Some guys have brought other brands. I just don't think the finish isn't quite there, especially for a car. Like, to me, I like the fit and finish to be, to look like it could have come like that from the factory. So that's why we use that sump only on all our engines.
In terms of that, I mean, we've talked about the sump so far, and also the availability of aftermarket oil pumps, and that's just touching on the wide range of options that are available now as bolt-on components, really high quality bolt-on components for the RB26. And Platinum Racing Products are another name that springs to mind, producing all manner of parts. Has that made it just like dramatically easier now to do a quality build on an RB26 compared to what you had 15 years ago?
Oh, definitely. Now you basically go and get a set of pistons and rods. Most of the big name brands are going to work fine. You get a nice sump. All these aftermarket companies now, they're building such high quality parts that there's pretty much almost anything you buy is going to fit really nice. It's going to look really nice. It's going to work well. It's so much better now than it used to be.
Yeah, I 100% agree. I don't think there's too many shoddy aftermarket brands, particularly when we're talking about engine internals. There's not a lot of fly-by-night companies out there, and for the most part, unless you're starting to look at 1500 plus horsepower builds, probably most of the mainstream brand names will do the job.
Yeah, definitely.
Speaking of pistons and rods, though, at what point with a stock RB26 are you beyond the strength of the pistons, rods, or the crankshaft? Where do you sort of draw the line? Because I mean, if you hold a stock RB26 Conrod in your hand, it's actually quite a beefy little unit.
Yeah, because they're really short as well. They are pretty tough. I personally, just for the insurance, I like to. Anyone that's going to say, look, I want 450 to 500 kilowatts at the wheels, I'll definitely tell them, look, you can get away with it at about 450. There are guys that have made, well beyond that. But reliability is sort of my first sort of the first thing I go for. So I would say anything beyond 450 to 500 kilowatts, I'd like to put a set of pistons and rods in it.
Yeah, I think it is cheap insurance at the end of the day, and I think what's really easy to overlook is if you have a piston disintegrate or a rod fail, it's going to take just about everything else with the engine out with it, and these engines are not cheap to source replacements now. So yeah, you do have to think of the big picture.
No, well, it's like my personal car, right? My 32 GT-R. We built a stock bottom end RB30-26 for it. I thought, you know what, I'm going to push this thing. I'd seen Robbie Ward from Rips over there saying that, they make 900 horsepower and then the piston falls apart. So I thought, I want to try. I want to see what's the go here. So I did it in my own car, and we were driving a Bathurst, and, it expired. And what did it do? Exactly what Robbie said. It busted a piston at 880 horsepower or so, So I could have built a motor for it, but, it's they are pretty tough, but how long are they going to last,
Yeah, definitely. And a lot of that also comes down to your application.
Definitely.
I mean, for a dyno queen, you can probably get away with it for a bit longer than something that's actually going to be beaten up hard on the drag strip or the racetrack. Now, one of the things we do see with the RB26 when it comes to building an engine is there are a wide range of different options, from using the stock RB26 block. There's the RB30 block, which I think back in the day was really looked down on as an option, particularly because it comes from fairly humble beginnings, being a low power single cam, pretty agricultural engine. Then you've sort of got the RD28, the Nissan diesel RB30 I mentioned. Then there's the likes of the aftermarket big hitters like OS Skyline with their 3-litre, HKS with their 2.8 high deck.
Yeah.
Have I missed anything? Oh, and of course the RB26 N1 block, which is sort of seen maybe as the holy grail by a few, but maybe isn't as great as it's sort of seen to be. Give us your insight there. What's the go there?
So I will not build an engine without getting a block tested, sonic tested, hardness tested, and crack tested. I will not do it. I refuse to do it. I don't care if it's brand new N1 block out of the box. I will not use it unless I test it. Just for the fact that I've had personally a block come in. It was new, and one of the bores had a real thin spot because of the core shift when they cast it. So I was just like, I'm not going to do it. It doesn't happen. I've found RB30 blocks to be a lot tougher than a 26 block. N1 or not, doesn't matter. The 26 blocks are really prone to cracking externally, as well as through the deck, just because there's not enough meat there. Deck thickness is not. It's nothing to write home about. It's pretty bad. So, RB30 blocks to me, I've always built RB30s for myself. I like a 30 with a twin cam head. I just think it's a really good combo. Heaps of grunt, and they're pretty reliable, and they're cheap. You buy a block and crank cheap, and you build it, and off you go. 26s, they obviously love the revs. You can rev them real hard because of the short stroke. They fit in the car properly. You don't have issues with fit in the engine.
What's the difference in the deck height between the 26 and the 30 blocks?
I think off the top of my head is about 38 millimeters.
Okay, so that's pretty significant.
Yeah, and it's all above the water pump. So it's from the water pump up to the deck is where that extra height is. Okay,
so what that means, you just mentioned about fitting properly in the engine bay, that's going to significantly affect the height of the cylinder head, and hence all of the components attached, inlet, plenum, exhaust manifold, turbocharger, etc. So there's quite a bit. It's not as simple as just doing an RB30 swap. There's actually quite a bit of fabrication work involved as well.
Yeah, that's right. But look, we've got combos that work. We do heaps of 32 GT-Rs with 2630s. 33 is easy. 33 GT-R fits with no problems. You don't have any bonnet clearance issues or anything like that. 34 can have issues depending on what bonnet's on the car. But 32 always has a problem. So, we've got chassis spacers and things like that to space across member down and bits and pieces. But it really depends on the application, what you want to use. We've recently started going towards the diesel blocks now because we've found the limit. 26s and 30s, they both have a similar deck thickness. So they're both around the 6 mil mark for a good block. Obviously, if it's really corroded, it's not even close to that. The diesel block, they're about 12 mil.
Wow.
Yeah. So we started finding once you have an engine that makes bulk torque, 1,000 Newton meters or so, then we're starting to see the deck distort and head gasket problems. So that's when we moved to the RD28 for the big hitters, guys that want to make over 1,000 horsepower, 1,200 horsepower, 1,300 horsepower. Bulk torque, and that deck thickness it helps a lot with head gasket integrity.
Are there other advantages with the RD28 block in terms of is there any difference in the bore thickness, or is it primarily in the deck?
Well, the bore size on an RD28 is 85 mil, so you can automatically go get a custom piston. Obviously, you're going to have a thicker bore size. So we normally run an 86 mil piston because they're easy to get. You can get them off the shelf from Nitto for their stroker kits. So we run an 86 mil piston. You're picking up, half a mil to a mil in bore thickness there, which makes a big difference.
But that's in comparison to going to a 20 thou oversized piston and a stock 26 block, which means it needs to be bored and honed.
Yeah, that's right. So, you pick up a bit there, but we've never really had a problem with splitting bores. I find that if you test the block and it tests up good, you're normally pretty safe there as long as your tune-up's right.
The deck thickness on the 26 block, and I've seen a handful of blocks, and I definitely never specialised in the 26, but I've built my fair share of them, and you'd pull apart an engine that was seemingly outwardly in good running condition, albeit stock, and a lot of those would actually show signs of cracking across the deck surface, even definitely in stock condition. So is that to do with that thin deck surface? Yeah, definitely.
I've seen standard engines that have never been apart that are cracked through the deck.
Yeah, okay.
So I find a lot of it, especially external cracks, they do crack on the outside too, is a lot to do with head stud installation. Guys are not installing head studs correctly. They're just bashing them in there and tensioning them, and oh, that's what the paperwork says. Cool, whatever. And then a couple of weeks later, there's coolant leaking outside the block. We've changed the way we do things probably 7 or 8 years ago now. Once we started seeing those problems, but they definitely crack through the deck regardless of what you do. Once you start getting really good studs and you're tensioning them to 100, 105, 110 foot-pounds, you just can't stop it. There's not enough meat there to keep the deck straight. And as well, once you start making a lot of torque, your studs aren't moving, but everything else is moving around the stud. And then you get more cracks and more head gasket failures and all sorts of things like that.
Sounds like a lot of fun.
Yeah, it's great.
Okay. In terms of the combinations that are available as well, because there is just about a limitless or mind-numbing number of combinations in terms of bore, stroke, etc., capacity. Ultimately, if you had a clean sheet of paper and you wanted to build a really responsive street car which had good bottom end torque, not necessarily aiming for 1,000 plus horsepower, what's your sort of go-to combination there now?
For me, honestly, strokers are great. They're awesome, whatever. Billet cranks are cool. First, on the street, I think that sort of 700 to 800 horsepower mark in a 32, say 700 horsepower in a 32 and 8 to 850 in a 33 or a 34, just because of the extra weight of the car. I think, an RB30 bottom end, factory crankshaft, really good pistons and rods, a nice cylinder head, don't have to go over the top, and like a precision 6870, or we've done precision 6466 on a 3 litre. It's a bit small, but we've gone 970 at the track with that street car aircon, no
It's
problems.
A fast car.
Yeah, look, and these cars are doing 20,000 Ks a year. They're driving everywhere and anywhere you can think of. And, they go to the track, you cruise around with aircon, you go to the track, you run a 970, you back it up 5 times, you go home, go to Cootamundra, do, 980s on an airport runway, no problems. And then you're doing 20,000 Ks a year, like a normal, like your everyday car.
So these aren't trailer queens. These are actually hard-driven cars that are putting in some mileage.
Yeah, that is I love that combo. That's what I've got in my car. I've had those combos in my car since, like I said to you before, the early 2000s. And they're so tough. You can, at that point, it's not on the edge where something small is going to cause a big problem. They can cop a hiding constantly, and they're reasonably priced as well.
Now, we've talked a little bit there about capacity and stroker kits, and the RB26 in stock form. One of the things that I was never a big fan of is the lack of bottom end torque. They do favour RPM, and they're not particularly responsive. Some of that comes down to the twin turbo arrangement, which I'll talk about, but again, it's an old engine design now from the 80s. It doesn't have a lot of technology, and one of the technologies we see on modern engines is continuously variable cam control. But this is where the aftermarket's kind of come to the RB26's sort of saviour, I guess, is the likes of HKS with their VCAM, and I know this is a system that you utilise. So can you give us a bit of a rundown? What is the HKS VCAM? What does it give the RB26 in terms of usability or any of the RB combinations, and how are you utilising it?
Yeah, so basically it's a constantly variable inlet camshaft, similar to like your VVTi on a Toyota or on like the AVCS on the Subaru. I believe it's actually they use the Subaru internals and make a new outer HKS. So the gear looks identical to a Subaru gear. So there's two. There's a step 1, a step 2, and a step pro. Step 1 is 30 degrees of adjustment. So that's what we use. I don't believe you need any more than that. The step 2 and step pro use 50 degrees of adjustment in the gear. The problem with the HKS system, it's designed for because obviously they only have their 100 RON or whatever it is fuel. It's designed for that kind of fuel, and a twin turbo car, say dash 5 turbos or something like that. So they're not really designed for big horsepower, so the camshaft is quite small. We had a car come in that had this system from Japan, but the customer wanted to go 3.2 litre, nice size single turbo. He wanted to make about 800 horsepower. So I said, there's no way this camshaft's going to do it. It's tiny. I think it was like 8 mil lift or something like that, and 240 degrees duration. It's a baby cam, So we went and we designed our own camshaft. We worked out what we wanted, got it to about 10 mil lift. Car made just short of 900 horsepower. It's great. And then we started to push it more and more and more. Currently, that same car makes just short of 1,100 horsepower at the hubs, and yeah, it brings on everyone that's seen the way this car performs. It brings on that. It's got a precision 72-75 now, and it comes on like we can bring that turbo on at 4,000 RPM and bust the engine, which is the reason why we went to the diesel block, because of that particular car. And just the torque is amazing. It'll come on like a baby turbo. It makes, I think at the moment, to keep the engine together, it makes sort of 20 pounds at about 4,000, and then we ramp it really like progressively to keep that torque curve nice and flat at that. I think it was last time we tuned, it was a while ago now, probably 2 years ago, somewhere around the 1,000 Newton meter mark, almost dead flat from 4,200 to, I think we revved it to just short of 9,000, and it makes, that's 36 pounds right up top just to keep that torque climbing, or to maintain the torque. But on the street, the thing's ridiculous. So that was the first one, and then we've built a couple others after that, and it just changes the engine completely.
Could you sort of maybe give us an indication of VCAM versus no VCAM, as close as we could to all other things being equal? What sort of additional boost response or low RPM response are we getting here in terms of boost threshold? Are you talking sort of 500 RPM or 1,000 RPM?
Obviously, depends on the turbo, So, but with this particular one, it'll come on sort of maybe 700 RPM sooner than it would normally, almost 1,000. But again, we've had to sort of hold back down low just so we don't hurt the engine, because it's making so much torque and so much power. Yeah,
okay. Yeah, that's not an insignificant change, and anyone who could get another 700 RPM of response, you're going to take it. All right, moving on to other sort of, let's call them Nissan idiosyncrasies with the RB. The fact that they came out with the individual throttle bodies in stock form, and I know that this has tripped up a lot of tuners in the aftermarket who aren't familiar with ITB plus boosted engines as a somewhat unique tuning strategy we have to use there, where we're taking throttle position and manifold pressure into account, sort of 4D tuning, so to speak. In your experience, I mean, most people with high horsepower, they'll chuck those in the bin and go straight for the likes of a Hypertune or a Plasma Man or whatever, and single throttle body.
Yep.
Do you see any pros with the factory ITB setup, and at what point do those become kind of the limiting factor?
I love the ITBs. Like, it's my thing. Anyone that comes in with a single throttle body, I ask them why. That's my first question. Why? Why do you want to put a single throttle? Oh, because it's going to make more power. It's not. Unless you're chasing 1,500 horsepower, okay, it's a different story at that point. We've made 1,200 horsepower with a bog stock factory inlet side. Like, not even enlarged throttles, not even an aftermarket like a plenum body, nothing, absolutely nothing. And we made 1,200 at the rehubs. Like, the car, where do you get to the point where you go, all right, I want more, or I need to change them, or that same car makes 1,300 and I can't even remember now. It was just on 1,000 kilowatts with enlarged throttle bodies, and we still haven't found the limit yet. So I don't know. At what point do you say, okay, I want to go single throttle now and change? That's one characteristic of a GT-R that I've always loved, that real sharp throttle response, like a sports bike kind of snappy throttle. I love that. So much so that we built our own drive-by-wire system for the multi-throttles. That was for my car specifically about 4 years ago now. And yeah, I really like it. I don't know. It's just me. It's just something about it that sort of gets me every time. It's got to be on there.
Yeah, I mean, I think that's probably a really good indication of what happens so often in the aftermarket, though, is people assume because they see so many GT-Rs with the aftermarket plenum chamber single throttle body that's an absolute requirement. But yeah, obviously from what you've just said there, it's probably safe to say that for 95% of GT-R owners out there in the world, the factory ITBs are probably absolutely fine. I'd also argue that maybe the lack of understanding from a lot of aftermarket tuners around what's required to get really good drivability and crisp response from the ITBs is possibly another issue. Any tuner out there will probably be able to work around a turbocharged engine with a single throttle body because that's just standard, but the ITBs really do need a slightly unique approach. So that's possibly one consideration there. The other one that's a real common issue, and this isn't just across the RB platform, but Nissan had this brainwave with their 360-degree optical cam angle sensor, which was applied to the SR, the RB, the VG30. There's probably more. Talk us through that. What is the problem with that cam angle sensor? Because on face value, having a lot of resolution so the ECU knows engine speed and position at a very high accuracy seems to be a good thing, but sometimes less is more. Yeah, what do you think about that?
Well, my main concern with it is you're essentially guessing where the crankshaft is. You're running two sensors off a camshaft, and you've got a timing belt that moves around. You know, depending on how tight the belt is, depending on how loose the belt is, you don't actually know where the crankshaft is. So it's never going to be right. With old ECUs, all right, the processing speeds were quite slow. Well, not slow, but slower than what we have now. So you get away with it. But as soon as we started seeing ECUs, well, from what I saw, that had faster processing speed, you'd get trigger errors and all sorts of stuff because it just doesn't, it's actually reading everything properly now at the right rate. So you really need a good solid signal from both the crank and the camshaft to know where everything is at all times, and just so it's reading things correctly. It's like anything, data, you need good data. You know, everything going to the ECU needs to be spot on. Otherwise, it's not going to be right.
And I think probably taking a step back, and just for those listening who maybe aren't quite following the conversation here, what we were trying to do is give the ECU a signal so that it knows, first of all, engine speed, and then just as importantly, engine position. And by engine position, what we're talking about there is really what we want to know is where the likes of number one piston is relative to TDC at any point. And we want to know that to the degree, maybe even tighter than that. But as you mentioned there, we're not directly measuring the crankshaft position from the crankshaft. We're measuring the camshaft position, and it's measured off the exhaust camshaft there, but you've got the cam belt between the cam wheel and the crankshaft. And I mean, if anyone's ever watched a YouTube video in slow motion of someone with a timing light on a supercharger belt, or even just watching the supercharger belt as an engine's revved on the dyno, and you see that whip that the supercharger belt gets, essentially we have exactly the same thing happening in the cam belt. So where there's definitely always going to be an error between, you know, what the actual crankshaft position is and what the ECU thinks it is. In some instances, for mild or stock engines, that's probably not an issue, but particularly once we start wanting to make 6, 8, 1,000 horsepower or more, you really want to know that your timing is exactly where you expected it to be.
Definitely.
I also see from the engines that I've tuned, this becomes more prominent, more of an issue when you've got aftermarket cams and valve springs. Do you think that's just down to the harmonics in the valve train becoming more aggressive?
Yeah, and the way that valve train reacts with the belt too. When you see really heavy valve springs, it cause all sorts of problems. But what choice do we have once we get to these kind of power levels with, big boost and all that? You've got no choice. So sometimes you just got to go away from the stock, stock cam sensor. I've never liked it to begin with. I just think it was in the same basket as the short nose crankshaft. I think it was never right, So you can't go wrong with a proper crank and cam trigger setup.
Yeah, so that crank and cam trigger is two individual sensors. So you're actually doing what we need, measuring the crank position directly off the nose of the crankshaft, and then a cam position sensor which tells the ECU whereabouts in the engine cycle it is, correct?
Yep, exactly.
So from your perspective, because there are a bunch of manufacturers making replacement trigger discs that get rid of the factory Nissan 360 optical trigger and go to maybe a 12-tooth or a 24-tooth trigger, reducing the frequency of pickups. Is that a viable solution in your opinion for any application, or is it still just a band-aid to an actual problem?
I definitely still think it's a band-aid. You're still guessing at the end of the day. Like you still do not know exactly what the crankshaft's doing compared to just because you got less teeth or windows or whatever you want to put in the factory sensor. It's still not right. It's just especially with ECU technology. Like I said, ECU technology now, they're so powerful. You really need to give them the best information that you can so that they work properly.
I mean, the ECU ultimately, like anything, is a case of garbage in and garbage out. So as you say, you've got to get those signals correct. And the two signals that are most critical to the ECU are engine speed and position, because all 100%. Of the fueling and ignition calculations are based off those two being correct, which is probably a good segue into talking a little bit about ECUs. And you've been in this industry long enough to see probably a dramatic shift in the technology available. And I mean, I know you're not doing the tuning yourself, but you're obviously involved enough with these decisions. So what have been the key improvements that you've seen in the ECUs we currently have access to?
Just the way, again, the processing speed of them now is so much better. There's so many more options and closed loop everything essentially now, we moved we basically, for street car stuff that is not too complicated, we'll run, Haltech Elites and things like that. And then once we started doing sequential cars with, flat shift and all that, then we started moving to the Motec M1 series. And after learning about that stuff, it's just out of this world. The things you can do with it, traction control and, again, all the closed loop flat shifting and fueling and everything. It's crazy. We all-wheel drive control as well. We're controlling all-wheel drive through ECUs now, whereas before you're relying on external control boxes. And you got 10 boxes in a kick panel, try to squeeze them all in there, and it was a mess.
I think definitely if you can do everything from the one tuning solution, it makes a lot of sense. And particularly with that GT-R platform as well, you've got control over that center differential and how much drive is going to the front. I mean, I've talked to enough people running these at into the sevens, if not faster, on the quarter, and being able to control how much drive is going to the front at what point on the drag strip is really a massive game changer. And particularly, as you mentioned there as well, when you're talking sequential transmissions with closed loop gear shift control, the technology to do that consistently, not only is it making the car faster, but it also really aids gearbox life. So I think that's something that's too easy for people to overlook. The other thing I'd say probably as a game changer for me has been the advances in data analysis and data logging that these ECUs have, particularly when you're running a car down the strip in 6 or 7 seconds. You want to get a lot of data so you can see what's going on. Same with on the racetrack as well. And then there's a lot more to it in terms of analysing the chassis and the driver as well.
Yeah.
That's another good segue here into talking about your involvement with World Time Attack. And this year, I understand that you are now looking after the XMCA Hammerhead. So
that's right. Yeah.
Can you, for those who aren't aware of what the Hammerhead is, can you give us maybe a quick 30,000 foot view of what the car is and what it's done in the past?
So the Hammerhead is pretty famous with World Time Attack. You know, when everyone thinks of World Time Attack, everyone sort of really, you know, a lot of guys love the Hammerhead. It was built by Murray Coote of MCA, and it's basically an S13 Silvia, SR20. Now it's Hollinger. It's got a Hollinger sequential in it that's now paddle shifted. It won back to back. I can't remember what years it won back to back World Time Attacks with Tim Slade driving it, and it's been in the top 3 for the last 9 years or so. You know, consistently top 3. It's pretty serious bit of gear.
I think one of the things that I like about the car, and I mean, obviously there is a significant budget that has gone into this car, make no mistake, but when you compare it to some of the other cars, like maybe the RP968 Porsche, there's a big disparity clearly in the budgets between the two cars. So I kind of always looked at it as a bit of a David and Goliath, and I think the Hammerhead's always sort of batted a little bit above, you know, where maybe it should have been, which is always cool to see. Now, you've taken over the operation of this car, so can you maybe give us a little understanding of what that looks like for this year's World Time Attack? What's going to be your responsibilities with the car?
Yeah. So essentially, all the mechanical side of things is taken care of by us. Brad Sheriff of Race Tech Tasmania, he's pretty much always tuned the car and done all the electronics side of it, I guess you could call it. So, well, he's done all the got all the paddle shift sorted, changed to Motec M1, Bosch Motorsport ABS now.
That car was always on Autronic, am I right?
Yeah, definitely. Yeah, that's right. Yeah, so up until last September, it could have been. It's always run on Autronic.
Which these days it's quite a dated ECU that's definitely really seen no upgrade and support for quite a while. So quite surprising it was still running it. Yeah,
that's what I said to Brad. I said, what ECU does the car run? He goes, it's always running Autronic. I said, really? Like, the car's crazy. Like, it's next level car and it's always run Autronic. He goes, yep. He goes, we never had an issue with it. He goes, but now to go beyond what it did, to step it up, it needs what he calls his GPRP Pro firmware package, and needs paddle shift. It needs the Bosch ABS and all that stuff. So it needed to go. It needed that step up.
Okay. So I mean, on face value, you might think that with one of these cars, well, it's going to be easy to go faster. Just add more power. But I mean, that's not really always the case. I mean, this car, at least as far as I understand, was sort of punching around 1,000 horsepower anyway. It is two-wheel drive. Yes, it does have huge downforce, but at some point there is a limit to physically what the tyre can put to the racetrack. You've got Tim Slade in the car, who's obviously a very talented peddler as well. There's no mistake there. So beyond the Bosch ABS and the paddle shift system, are there any other changes to the car that have been made in the aims of improving that lap time?
So the GPRP Pro firmware that's in the car now, it's all torque request modeled. So Brad's designed this whole package based on his race car, and combines traction control with grip level and then torque request. So that's essentially what's going to make the car go faster. Because originally it was making about 800 horsepower. Then it was stepped up to a bigger turbo, and now it makes 1,050. But obviously, being a rear-wheel drive car, it's not as easy as just feed it everything and see how it goes. So, yeah.
So basically, what I'm reading from that is using Brad's firmware. And for those who maybe aren't following there, the Motec M1 platform does give developers the ability to essentially write their own code in terms of how the ECU will work. So really, in that respect, the M1 ECU is just a black box, and it'll do whatever you want, provided you're smart enough to come up with a solution, which is, as you mentioned there, Brad's GPR Pro package. So that's, I'm guessing, I've only heard of this now, that's his bespoke firmware. Yeah. And it sounds like what you've got the ability to do there with the torque modeling or torque request is essentially do a better job of modeling the requested torque from the engine to the amount of traction that is available. So it's all about basically getting as much power to the track as the track can handle without ending up in wheel spin. Is that sort of a good summary of things?
Yep, that's it. So it calculates, like as I said, it calculates allowable wheel slip, and then it also knows the grip based on obviously all the G-forces and everything that's in the background, all the background maths, and then based on that, and how much torque is dialed in. So the torque is dialed in via a rotary dial, and then your throttle obviously as well. So you give it a max number on the dial, and then whatever where your throttle position is, and then it knows how much grip you have, and then or how much theoretical grip you have, and then it'll let it wheel spin however much you allow it to, and then it calculates everything from there and controls everything from boost to timing and all that associated.
With the miracle that podcasting is, this episode is going to undoubtedly come out after the 2022 running of World Time Attack. So we are attending, and we'll be sure to look you up and see if we can do a more in-depth interview there for our YouTube channel. But for those listening, after this podcast come out, you can probably check back there and maybe find out exactly how all of that torque modeling actually works in the real world, as opposed to theoretically like we're talking here. All right, the last topic I want to talk to you about today, Anthony, is your actual shop, because we do have a wide range of different listeners on this podcast, and for some of them they are workshop owners, or maybe those who are looking into starting their own workshop. So I'm interested, maybe could you give us a real brief overview of the size of your business that it's grown to at this point?
People laugh, but there's only two of us here.
Okay.
So yeah, just me.
Real hands-on then.
Yeah. I'm not the managerial type. I can't do the whole office sit down and do that stuff. I got into this trade to sort of build things with my hands. I've always been like that, and when people come in here and they talk to me and I show them what we do and how we do, they sort of are a bit taken back by the fact that we do all the fabrication here, or I do all the welding. All the wiring harnesses are built here by either me or the other Anthony, who we call Junior. Engine building, we build all our engines here. We put all the cars together. We essentially do everything here, the two of us. And I've just got a third guy on now that does 3 days a week with us. So that's helping as well. But yeah, we don't have a big team. I'm not really interested in having 10 guys and, random people working on cars. I've got an emotional attachment to these cars because I just love them, So I want to work on every single car that comes through the door.
That's probably quite a unique approach, where I see a lot of the performance workshops that we visit all around the world, where growth has been the number one driver and bigger is better, more staff, more lifts, and more cars in and out the door. And obviously somewhere along the way, it's very easy for those sorts of workshops to kind of lose that personal touch, or quality control probably is the more prominent aspect
definitely.
there. And I think as a workshop, your reputation is only as good as your last build. So do you find, is that why you've chosen to keep your team so small and keep that personal touch on every car to make sure that you know everything that's leaving your workshop is exactly 100% complete and perfect?
Yeah, definitely. So I'm very picky with how the cars get put together. Everyone that comes here, they know. And they see the jobs, and that's why they come here, because we want to preserve these cars. I don't like cutting cars. I don't like making extra holes. I don't like any of that stuff. So everything has to be done a particular way. I'm very, very picky with even down to, I don't know, which way a zip tie is facing. It has to be the way I want it. And that's why Junior and I, we've got it. He works the same way I do. He knows exactly what I want. He knows exactly how it needs to be for me to be happy. And that's why we are the way we are,
Yeah, I can respect that, and I also share your passion for the attention to detail there. One thing that will get my heart rate up very quickly is seeing a zip tie that's been hacked off at the end with a pair of side cutters. Not only is it a safety hazard because you're going to cut yourself up on it, but come on, it's not hard to use a flush cut and actually finish that nicely.
Or even a razor blade, it's not that hard.
Absolutely. Pet peeve of mine, 100%. Yeah. I hate that stuff.
I can't stand it.
In terms of the other aspect of business operation, I think a lot of people that get into running a performance workshop because they're passionate about building cars, because they're good at working on cars, quickly realize that there's actually a lot more that goes into a successful business in terms of quoting, invoicing, dealing with customers, parts, getting the parts in the door and managing all of that. So how have you found that? How do you deal with that? Is that still something you're dealing with?
Yes. Well, so originally the business was started by my wife and I. So it's a family business. So my wife will do, she'll pick up parts and order stuff and go and get this and that and pick, drop blocks off at the machine shop or pick them up and all that stuff. So that obviously helps. Essentially, I'm doing all the quoting still, all the invoicing, because you know what this industry is like. It's not like you can buy an invoicing software and everything's in there, everything's one-off, custom, this, that. You gotta know, it's you really need to keep track of things. It's hard, but you gotta know what goes into each car, and you got to be able to remember that. I find it really hard to write things down because we're so busy and I'm always all over the place. But luckily I've got a good memory and I can remember what goes into cars and all that stuff. And at the end of the day, then I can just write down, whatever happened on each car during the day. But yeah, it's not easy. But if it was, everyone would be doing it,
Yeah, absolutely. And another real common problem, maybe the most common complaint I hear in the performance industry is quoting from performance workshops. And the usual story is the customer gets a quote for X for a certain amount of work being done, comes to pick up the car 2 months later and finds that with no communication, all of a sudden that bill is now 2X or something of that nature, basically. Yeah. And I mean, I've been through this. I ran a performance workshop for 13 years, and I'll admit quoting is hard because a lot of what we did was one-off. So you're trying to quote a job that you've never done before and you'll probably never do again. I'm guessing you're doing a lot of relatively repeat work given that you focus on the GT-R, but is that still an issue for you? And if so, how are you dealing with that?
Quote-wise, I'm very detailed with my quotes. So a lot of customers, they sort of get a bit turned off by it because they come in, they'll go, okay, I want a quote for this and that, and they expect it by the next day. I tell them straight whenever they come in here, look, you come and see me, I do my quotes on the weekend when I'm sitting at home. You'll get it in a week or maybe 2 weeks. But when they get the quote, everything is on there, literally everything. We know now what's involved in a fuel system for, from going from a factory car to a 1,000 horsepower car. We know, I can quote it, every part, fully itemized, no problems. Same with engines. We know exactly what goes into the engine, so we can quote them, no problems. Like you said, because we do GDRs mainly, it's a little bit easier because it's not often that you get someone that wants to go, complete opposite to what you tell them is the right way to do it. So, you get an idea for it and you say, look, this is what it is, give or take 10% or so, and they're normally pretty close.
Sure. I guess, again, it comes from that experience of doing those combos over and over again. It makes it that much easier for you to get it right.
Yeah.
And is there also any issues with maybe aligning the customer's expectations with a budget? Is that still a problem? I mean, I dealt with a lot of customers who, had stretched themselves financially to get the car in the first place, and maybe didn't quite realize how much it costs to do what they wanted.
Yeah. Well, I always tell people the worst case scenario, and then at the end of it, if it's cheaper, they're happy because it costs them less. So. But yeah, I've seen quotes from other people where they come in, they go, oh, look, I got this quote from whoever, 20 grand for an engine. And you go, okay, you look at it and you go, okay, well, this, all this stuff's missing. And then they freak out when you tell them, oh, that $20,000 engine is going to cost you 40 by the time it's sitting in the car. And then they go, oh, but it doesn't make sense. I said, well, you have to compare apples with apples. And then you sort of, with us normally, because I'm very transparent, most people sort of understand. And we pick and choose our clients as well. So we've got that much work that we're able to pick and choose. And you definitely know when you just start throwing numbers around who the serious ones are and who the ones that are sort of bit of a dreamer. Look, everyone's got their own situation financially.
Of course.
So you got to try and be a bit, you have to be very transparent at the end of the day, that instead of just worrying about getting the car through the door and, sort of starting a project and not finishing it. I always tell the customers, I'd rather you not come here and not spend $1 with me, but have a running car than get halfway through a project and hate the car and sell it in bits.
Yeah, I think that's something that a lot of workshop owners should take note of, because it is uncommon. I think a lot of workshop owners are just hungry for the business and will take whatever comes their way. And sometimes I think your reputation is made by the customers that you fire as opposed to the customers that you do work for. And I think, again, I'm putting my workshop owner hat on here.
Yeah.
You can't be too afraid to see customers that you shouldn't be doing work for because their expectations just aren't aligned with reality. And, that's going to save you some headaches in the long run.
Yeah, that's the hardest part, learning to say no. I struggled with that for years. Probably, I'd say probably a good 10 years I struggled with that, with saying no to people. I felt like I was letting people down, and I've never been one to do that. But yeah, since we moved into this bigger shop and had that much work on, it became easier, obviously. It's easier to go, look, I've got so much stuff here. Where would you like me to put your car? I can't do it. I'm sorry, but you can obviously see how much stuff we have going on. I can't do it. Or if you're happy to wait, we'll work something out.
Sure. All right, let's move on towards wrapping this thing up, Anthony. We do appreciate your time here. We've got the same 3 questions that we ask all of our guests at the end. And the first of those is, what's next for you in the future? Where are you sort of headed? Any big projects or changes of direction in mind?
To be honest, I didn't even think we'd get to this point. I was happy just working by myself in a little 200 square meter factory unit, but I'm one more person full time would help a lot. And I think that's I'm happy at that point because I've still got control, which is a big thing, like I said before. As long as I've got control of how things are done and what things are done, I'm happy to just maintain,
Yeah, it's definitely that happy point in terms of a big enough workforce to get through the work and be productive without, as you say, losing control over the quality that's going out the door.
That's right.
All right, next question. Just given your path so far, your experience, everything you've gone through, is there any advice that you'd give to a younger version of yourself to maybe fast track your experience, or maybe overcome some pitfalls that you've gone through?
Learn to say no.
Yeah, coming back to that again.
Yeah, learning to say no. And one thing I've always sort of learnt now after a while is don't stay stagnant. Once you get comfortable in business, it's time to push out of that comfort zone and move forwards a little bit. Doesn't have to be a massive step, just a little bit. Move out of your comfort zone. That gives you a bit more drive, because if you stay stagnant, then you can slack off, and then you can start going backwards. That's me anyway. That's what I found.
Yeah, I think that's good advice. And I think as well, if you become complacent or stagnant, as you mentioned, I think that's the time as well when your competition will catch up and maybe potentially surpass you. I mean, for me, that's why I also still am passionate about the automotive industry, because there's always something new to learn, and there's always another technology to take on board, or another direction to go. It's never ending, which is a pretty cool thing. All right, last question for today, Anthony. If people want to follow you, check out what you're doing, where are they best to do that?
Mainly Instagram, a little bit of Facebook, Dartone_racing on Instagram, and just Dartone Racing on Facebook. They're the two main socials.
Perfect. All right, we'll drop those links into our show notes so people can follow along. Look, it's been great chatting and getting a little bit more insight into one of the legendary JDM engines. So we really appreciate you laying it all on the table there and keeping no secrets. So thanks heaps for your time there, Anthony.
No dramas. Thanks for having me.
All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpaacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpaacademy.com/courses.